Welcome to my YouTube channel where we discuss research and everything relating. In today's video, we'll be looking at understanding p-value in research analysis. So many of us has heard p-value, but we find it very difficult to understand what exactly is p-value and how do we actually use it in statistical analysis and hypothesis testing. But before we go into the video, don't forget to like and to subscribe. I also want to welcome all our new subscribers and first time viewers, and also those who have been with us for a long period of time. Thank you for watching. Now let's dive right in. What is p-value? A p-value is the probability of obtaining the observed effect, or more extreme, assuming the null hypothesis is true. In a video where I talked about hypotheses, I explained to us what hypotheses mean, what type of hypotheses we have. If you've not watched that video, you may find it difficult to understand what I'm explaining right now. So you can do well to check that video for a full comprehension of what is being discussed. Now, p-value helps researchers assess the significance of their results. That is, it helps us know if there is actually a significant relationship between the variables that is being tested. P-value also, there is a rule for p-value that generally states that the lower the p-value suggests stronger evidence against the null hypothesis. In null hypothesis, we know that we say that there is usually no significant relationship. So if it is lower, if your p-value is lower, we then say that we would reject the null hypothesis. Let's move forward so you would get the full grasp of this explanation. Now, interpretation of p-value. P-value is less than or equal to 0.05. Whenever you carry out your statistical analysis and your p-value is less than or equals to 0.05, we say that there is a strong evidence, hence we will reject the null hypothesis. For instance, if we are looking at the topic that says there is the effect of exercise on weight loss, and after carrying out our statistical analysis, we find the p-value to be equals to or less than 0.05, we would say, if our null hypothesis in that case study is there is no significant relationship between exercise and weight loss, we then would reject that null hypothesis because our p-value is less than or is equal to 0.05. But in the case where our p-value is bigger, is greater than 0.05, we will say there is no enough evidence to reject the null hypothesis, hence we would accept the null hypothesis. So what this generally translates to is that the smaller the p-value, the stronger the evidence against HO, that is null hypothesis, so we will reject our null hypothesis. Now let me quickly do a brief discussion of null and alternate hypothesis. If you want to get a few understanding of this, refer to the video of where I explained the hypothesis formulation. Null hypothesis, which is usually represented by HO, which is what we have in the brackets here, capital letter H O. There is no effect or difference that exists between two variables. While the alternate hypothesis or H1 states that there is an effect or there is a difference. So if the p-value is smaller or is bigger, it helps us tell the direction in which, or the hypothesis in which we would accept. So if the hypothesis is smaller or is up to or is equal to 0.05, we know that we would accept alternate hypothesis and reject the null hypothesis. But when the p-value is bigger or greater than 0.05, we would accept the null hypothesis and reject the alternate hypothesis. Examples of p-value in research. A study tests if a new drug lowers blood pressure, and then when we carry out our statistical analysis, the p-value is equal to 0.03. that there is only 3% chance of getting this result if the drug has no effects. And since 0.03 is lesser than 0.05, the null hypothesis will be what? Rejected. They say, and then we would accept the alternate hypothesis, which says that we would support the effectiveness of that drug. That is, that the new drug actually lowers blood pressure. I hope you do understand. Now, what are the common p-value threshold? When p-value is lesser than or equals to 0.01, there is a strong evidence against our null hypothesis, or HO. But if 0.01 is lesser than our p-value, which is 0.05, moderate evidence against HO. Do you understand? And when the evidence against HO is weak, we would usually accept our alternate hypothesis and reject our null hypothesis. But if it is greater, that is, there is no strong evidence against our HO, we would accept the null hypothesis and reject our alternate hypothesis. What are the limitations of our p-value? It does not measure effect size or practical significance. It is usually influenced by our sample size. That is, if the sample size is large, you can always have your p-value may be low even for small effects, and you cannot usually prove causation. You can only indicate statistical association. In conclusion, the p-value is a vital tool in hypothesis testing, and it helps determine statistical significance, but should not be used alone. If you have watched this video up to this moment, I hope that you really are following and you've gotten some insight into what p-value means and how it can be utilized in statistical analysis. Also, how you can interpret them in statistical analysis. Don't forget to like and to share. Thank you for watching. See you next time.